This is another option, using the aerial to rescue somebody from an elevated place. And I know I'm not the biggest fan of putting ropes on the tip as a fixed system, a fixed line system, but it is an option and it is viable, and there are some pros, and we're going to demonstrate the pros here, talk about the cons too. What we're going to do is build a combination of like a fixed line system in addition to some adjustable rappel system. And so where does this have applicability? Well, it could be a man-made structure, any natural structure, a ledge. I mean, the top of a dump truck, somebody's having a traumatic injury or a medical emergency or whatever, even a downed firefighter in a structure fire, commercial. We can go for speed, and granted, like the whole OSHA regulations on moving live loads, we work in a very dynamic environment in emergency services. So we're always doing this risk-benefit analysis, this hazard consequence matrix. The pro to this is speed, because in the end, speed is the ultimate metric for a rescue. Well, we want to do so within some sort of constraints of like relative safety. And it involves very little rigging, relatively, compared to like using it as a high point or a high directional. And we're able to move the aerial with, I'd say, relatively minimal risk, as far as having lines further downstream. As you would in a high point, you have directionals and devices that are anchored to the base. Here, we just tie them off to the tip or near the tip or that last fly section. And now it's protected from any further rotation, elevation, or extension. It has no bearing on the fixed rope part of it, so this is protected. So we're going to mitigate those inherent risks that way. We're going to put a rescuer on. We're assuming that the only way to access and the only way to viably egress is to get to that elevated point via a ladder. So we can't use an elevator, no stairs, there's no path we can walk around. So we're going to put a rescuer on the fixed lines to make access. And the advantage of that is, with radios, a rescuer communicate with the engineer to pinpoint exactly where the tip needs to be. We only want to put a single person load, so 1 kilonewton. So no two-person loads. So that's, I guess you could say it's a con, but the silver lining of that is we don't have to worry about load amplification or force amplification on a high directional. We don't have to worry about torque forces at the base. We don't have to worry about our load capacities for changes in elevation and extension. It's a single person load, can handle that all day long, regardless of where any of that is. So it simplifies our lives quite a bit. We want to initially rig everything kind of low, because the more rope we have in service initially, that's less workable height on the aerial. We want to maximize the workable height we have. We just don't know. Sometimes, like, we're shooting pretty far, and once we get there, we need to be able to also continue to elevate or raise or lift. And the longer we initially start, it could hinder our ability to lift further on down the rescue. So we want to start by rigging this pretty low. Here's the tip of the aerial, it's almost to the ground. Our fixed lines are set. We're going to put a rescuer in here as we would on a rappel system. So standard descender with a backup. Let's look at like the fast way to rig this. So let's shoot up here. Okay, minimalist, I only need ropes. So I have 2 ropes to take the 2 terminal ends. A fast way to do a 2-point anchor around the rails and to have like the tail as a static rappel line or a fixed line is to just to do a load sharing bowline. So view from the top side. 2-point load sharing bowline. I have other videos on that. Fast, easy, doesn't require any other gear, no prusiks, no webbing, no carabiners, and I duplicate it. So 2-rope system. Even though like, oh yeah, these ropes are going over and it looks like a directional, like the resultant force is the loaded line, and there's no force amplification because the anchor is on the actual member itself. So, and we don't have to worry about anything. We don't lose height here by tying these somewhere down lower. We maximize our height. I don't believe that aerial ladders should ever be used as a belay system. But what's the alternative for a repeller? If he screws up on the rappel and he's on a single line, like we have to make compromises somewhere. So independent self-belay on an ASAP. And in reality, a failure, it's not going to create super high shock forces on the tip. So we're gonna make a compromise and deem that acceptable. Standard system, independent self-belay on the sternal. He's got a descender to make up the difference when we actually come up to the roof, and anything that he's bringing up, in this case a litter, the remaining bags of rope, splints, based on what we think the problem is. A Zoll monitor for diagnostics, why not? And he's ready to go. We clip all that to the spine that the descender is on, just like a rescuer-based pickoff. We don't want to clip all this load directly to our rescuer. It's on the carabiner that's on the spine of the descender, so he's not bearing the load, and we're ready to go.
Where to go?
Rescuer made it to the roof with all the gear he needs. He's going to do a disconnect. He's going to come off all the lines. Now the caveat here is, if this is an exposed area, like what's the risk? If he comes off the lines and then he falls because it's exposed, well, that's a problem. So that's where like creative problem solving when you get up here is key. In this case, it's flat. He's going to come off completely his system. It is litter prepped, get all his diagnostics, his splitting material, figure out what's wrong with the patient. If we need more resources, we're not going to move this ladder again. We're going to have somebody else boogie on up the tip and rappel. And that's what our rescue number 2 is doing right now. So over here, rescue number 2 is going to climb the ladder. He's going to rappel off the tip, and he's bringing some other medical gear, whatever the first rescuer asked for.
Bet you guys are gonna start liking these knee pads.
Second rescuer, third, fourth, whatever. Second rescuer is up, assisting the primary rescuer, packaging, assessing, stabilizing, getting ready and prep for transport. Now, the fixed lines that we had, we came off and they're loose. The fast way to do this is just to establish a midline knot and then hook our bridle in. I mean, you can do Pro-6, but why add more gear? I'm just gonna do a butterfly with the pair, so it's a double butterfly. And where do I put it? Anywhere where I think the bridle's gonna clip into. So basically that height right there makes it easy. So if I could put my loop right there, that's a plus. So a double butterfly. Doesn't have to be pretty. In the end, it just needs to be actually a double butterfly. Okay, so we've established our yoke right in through here. 2 ropes, 2 carabiners. This is bomb-proof. For speed, I don't know if there's a faster way, so it's about as fast as you can get right there. Okay, 4-point bridle in. On this particular stretcher and bridle, it doesn't come with its own internal lashing system, but it does have the external lashing system. So if we look at the black cross straps, that's the external lashing system. There's nothing to prevent the patient from sliding out the foot of the head, and the internal lashing is what unquestionably secures the patient into the litter package as a whole. And since we don't have that, we just throw in a pick-off strap, harness them up, and make this somewhat not super taut, but minimal slack in that. So he is unquestionably in the system, does not need any additional connection points. Do we have to jump these tails into the litter? No, you don't have to. If it gives you a warm and fuzzy, great. Now, we're ready to hoist them. The excess rope that we're not using for the 2 lines, we can stuff them into the litter, or we could take advantage of the use of tag lines. And so that's what we're gonna do here. So we now have just conveniently 2 tag lines at our disposal. If we raise it as is, this litter is gonna wanna bang into the railing. So our rescuer that has the radio comms with our engineer is gonna say on the radio, raise and extend, try to keep this thing straight up on the lift. If there's any flux, that's where our tag lines come in. He'll operate one tag line to keep it kind of in plumb or keep it away from that wall. 100%. Meanwhile, our other rescuer can chuck the other end of the rope to the ground, yell rock, and that's a tag line for our ground team. Makes it really super fast and easy.
Copy, raise and extend.
There we go. I just adjusted myself.
So, last minute check, we want to make sure that the litter is flat.
Rock!
Down it goes.
Stop. Rotate counterclockwise. 10 feet.
Copy, counterclockwise.
Okay, at this point, we've cleared it. Rescuers have done their job. We're gonna transport to a waiting ambulance. So now it's just up to the engineer to do their thing. They have good visual, and we have a ground tagline.